What are some flaws and limitations in the system and nanotubes?
Flaws and limitations with looking at carbon nanotubes. Okay. Well, carbon nanotubes are just carbon. If we had a wish list and we wanted to specify exactly what we wanted in a carbon nanotube, we'd want them much, much longer in length. We want them much more uniform in their composition, much more reliable. If we could achieve those two things, then you could spin them into fibres essentially as large as you could make. So you could make a single fibre, right, that might be able to lift a ship. So if you could make your nanotubes long enough and strong enough and uniform enough. So that's in terms of manufacturing. But Mother Nature provides us with some challenges. Right? You don't see nanotubes around all the time. They're quite difficult to make. So better manufacturing technologies is one issue. Another issue that people are quite worried about in the context of nanotubes and carbon nanomaterials is the question of whether or not they could become the next asbestos, whether or not they could lead to a new generation of dust diseases. Why is that important? Well, asbestos is a very interesting mineral. You dig it up out of the ground, but it's a very fibrous mineral. It's the most remarkable material. You can have a stick of asbestos. You could put one end in a furnace. You could hold the other end with your hand. It's such a poor conductor of heat. And that's why it was so widely used in all sorts of different applications, particularly in furnace engineering and in thermal insulation, fire retardant, stuff and all that sort of thing. But what people discovered subsequently is that the fibres in asbestos are very sharp and very spiky in nature, and they get lodged in people's lungs, and the body doesn't clear them out very well, and in fact they become like little irritants. So you know, for example, if you have a mozzie bite or something like that, you have a local irritation, but then that disappears after half a day or something like that. The problem with the little things like asbestos fibres is they get inside your lungs and they cause an inflammation indefinitely. And although they're not quite sure how it works, at some point that irritation in some people develops into the forming of fibrous material inside your lungs. So your lungs start to lose their function, which is what the mesothelioma disease is, which people get if they're exposed to asbestos. So what people are very worried about is some of the characteristics of carbon nanotubes are similar, have some similarities to those. They're extremely strong, they're fibrous, they've got a very high aspect ratio, they don't break down easily. So people are thinking, no. So if they were inhaled, if someone was exposed, say in their work environment or in their house or in sport or in their job or something like that, are we possibly going to go down the same pathway with nanofibers? And so that's one of the things that people are quite worried about at the moment. And so the approach that people take generally is that they treat all fibres as if they're dangerous. And so when people are handling these sorts of materials, they'll wear breathing protection, they'll make sure they're encapsulated. So for example, if you look, you might have seen an old house that's got a asbestos cement veranda or something like that. It's very common in the 1950s and 1960s. You might see it around some roofing, which is the old corrugated asbestos or fibre roofing. If the material is encapsulated and painted, it's perfectly safe. It can stay there forever. Yeah? It's only when it becomes free that it's a problem. So people are taking the same approach with carbon nanotubes to try to make sure that we don't end up with problems that we could have anticipated.
With the flaws of nanotubes, how can we improve them?
Improve the nanotubes? Well, if if you're thinking about how you, well, there's really two issues. First of all, we need to understand better how to grow them. And so, for example, and that's a process of learning. One of the things that made a big difference in growing carbon nanotubes is using a catalyst. So you're using a little tiny iron nanoparticle, which provided a nucleus for growing a nanotube. Right? So if we can understand better how the nanotubes actually grow, understand the mechanism by which they actually grow, then we'll be able to grow them much longer and with higher strength. Another interesting issue is, we mentioned just a moment ago that one of the interesting things about these types of carbon is that you can put additives into them so that you can tune up their properties, make them an insulator or make them a conductor or something. If you can better control the composition of your nanotubes, you can potentially use a nanotube as a transistor element, so as a molecular element in an electrical circuit. So remember in the talk that I gave today, we had Moore's law, where it was showing how many more little elements there was going to be in a chip every 18 months. We're up now over 1 billion. So if you were to pull apart one of your computers and look inside the processing unit, you'd find that there'd be more than 1 billion transistors in that one little thing. These little transistors are just switches, right? It's just, you put in an input and it either says yes or no. But when you assemble them together into big arrays, they become what's called logic gates. And so when you assemble all those together, it becomes a processing unit that you can give an instruction to, right? Okay, computer, make my screen show these characters. Okay? But the trouble is that we're getting to the stage where those little transistors are so small that you really can't make them any smaller using the current technology. So you've got to go from a top-down approach, which we talked about, to a bottom-up approach. So rather than taking big things and making them smaller and smaller and smaller using lithography, we have to start finding Lego blocks, in other words, little molecular pieces that we can put together one by one to create a structure. Yeah. So being able to control